All right. So here we'll be still talking with the trigonometric functions, but we'll look at some trigonometric identities and we'll verify those. We'll do some math, and these sections and chapter will look like more like algebraic, because we have all those trigonometric functions. We'll know some trigonometric identities, and based on those we'll do some math and see and verify some equations and some relations between the trigonometric functions. So what are the fundamental identities we have in the trigonometry? I think we have seen some of those, not all. Like the first ones, the reciprocals. We know some of the trigonometric functions are reciprocal to each other, like sine and cosine, cosec, sec and sine, sec and cos, tangent and cos and sec. All these are the reciprocal of each other based on their ratios. And we also, I think, know these, that the tangent is sine by cos, cotangent is cos by sine, and there are some identities coming from the Pythagoreans, which are sine square plus cos square equals to 1, 1 plus tan square equals square, 1 plus cos square equals to cosec square. Remember, during the test you will have access to all these identities, so you don't have to memorize any. All you need to know is how to apply it, do some practice, so that you will know actually when to apply which one. Okay. And also based on the even and odd identities, because you know some of the functions are even functions, some of the functions are odd functions. Based on those we have all these identities here, even odd identities. Now just looking at these, can anyone here quickly tell me which ones are the even functions out of 6? Look at the six trigonometric functions for their even and odd identities. Can you check and quickly tell me just from here that which one are the even functions? I think the sine, cos and sec, because look at these two. So remember the definition of, because I just try to make sure that we understand, because we covered we know the even and odd functions from chapter 1. We just want to make sure that we understand it and we don't forget. So let me remind that for you. So f of minus x equals to f of x. That was the definition of any even function. Try to match it with the cosine. Look at the cosine, how it works. Do you see the match here? Even that is true for sec, because which is true for cosine, that is true for sec, because they are reciprocal to each other. So the sec negative x is also sec x. Now one of the reasons, little bit detail, because I don't want to go that detail in almost all of the topics, because some of the topics are so interesting that I sometimes cannot resist myself. One of the reasons that come into the picture, because you remember we have 4 quadrants and they have 4 all sine, tan, cosine. Remember which ones are positive and negatives in which quadrants? All sine, tan, cos. One of the reasons why this is true, because if you take the negative x, when you start, you always start from the positive side of x, right? When you take the negative x, you go to the 4th quadrant, okay? And for cos and sec, this quadrant is positive, okay? And that's why any cosine and any sec, when they have negatives, that is still positive, because this is the positive quadrant of cosec and sec. Cosine and sec. Again, I'm not going to that detail. It's just like a highlighting part that I just wanted to make sure that we understand that why that is only true for cos and sec, but nothing else. And that was the reason why that is true for cosine and cosec. Okay, so let's go and move and see what do we do. But remember, some of the trigonometric identities will do some tweak and twist to verify other things. For an example, we know that sine square plus cos square equals to 1. From that, we can write sine square equals to 1 minus cos square, right? I'm saying from here we can write sine square equals to 1 minus cos, or we can write cos square equals to 1 minus sine square. That's the same thing, but again. So let's see whether we can check something. So here, this is our first identity we are trying to check. Now, the question is saying that simplify the given expression. Now, remember, to simplify any such identities, you always have to use those identities that we looked at the beginning of the slide. I think you may not remember all of those, but you know some of the functions are reciprocal to each other, and we'll try a couple of ones today. We'll not be able to probably finish this section today. So let's see how we can simplify it. Cos x, sec x minus cos x. If you do it, so let's take the bracket out first and let's distribute it. So what do you get? Cos x times sec x here minus cos square x. Do you understand what I did? I distributed the cos x. I took the bracket off and then I multiply sec x by cos, and I multiply cos x by cos x. So that's how I get cos x times sec x minus cos square x. Just like the regular algebra, okay? The only thing is this time we are dealing with the trigonometric functions. Now, what we can do next? Any guess? You know, I know what will be the solution. I can do that, but I'm just trying to see whether we understand what can be the best next thing. What we can do? Can we apply, you know, objective is to simplify it, okay? Most of the cases what I understand by simplification is to make it simple, to make it smaller, okay? To do that, we might have to cancel out something. Can you do any math here to simplify cos x times sec x? Any guess? Do you think they are reciprocal to each other? Cos and sec are the reciprocal to each other, right? So we can apply that x times sec x. You can write it as 1 over cos x. You can write cos x equals to 1 over sec.
Because they are reciprocal to each other, we'll just still stay with cos square x. Now here, you can cancel out cos and cos. So you'll be left with only 1 minus cos square x. Now 1 minus cos square x equals to
Sine square x. You know, we just talked about that 1 minus cos square equals to sine square. This is how you can simplify a lot of trigonometric functions. I'm saying composite functions. This is not composite ones, but these are like compound functions, I would say. A lot of compound functions, you just can apply some trigonometric identities and you can simplify it. Now you see here cos x times sec x minus cos x equals to nothing but sine square x. But it was not visible at the beginning, right? But when you start working on it, or when you do a lot of practice with trigonometric functions, those will be visible to you for sure. But probably tomorrow, I'm saying when we'll be dealing with all this kind of verifying identities, I'll give you all the formulas first so that you can look at the formulas in front of you and then you can see which one to apply where. Okay. Now let's see, you have any question here? How we applied what? Let's try this one. I think there is a typo here. Oops. Okay, there is a typo here. Just think there is a G here. Do you see there is a G? Just assume that is multiplication. I was trying to correct the typo, but that was an image, so I could not type it in. I tried to correct it. So just assume the function is, now you have, if you look at this one carefully, you will see that this one has left side and right side. This is an equation, okay? And the verifying identity means that the left side, so you will apply some trigonometric identities in the left side, and you should be able to find that is cos x. So let's see. Just assume that G is a multiplication. That's not G. That's just sine x times tan x. So now at least you know the destination. So you know that you have to solve the left side. Not solve, you have to simplify the left side, and you have to find the left side equals to cos x. Let's see whether, let's do this. Let's write this equation, and then I'll go back to that slide where you have all the identities so that you will know or you can find which one to apply. Let's write this one. So the equation is sec x minus sine x times tan x, and you are trying to find whether that is equal to cos x. Let's go back to the slide where we have all the identities. Now we are looking at all the identities right now and see what we can do here. So you will be working with the left side. Let me pause for a couple of minutes because I can solve it for you right away, but I want to just see whether you can try. You don't have to solve it, just try and see whether you can do something. Remember, in such trials what happens, a lot of times you will probably go to some dead ends. Okay, don't worry because that's so common. When you practice, you will see you will go to some dead end and you will always start over for sure. Anytime you go to dead ends, okay? Because some of the trigonometric identities you can apply, but you will not be able to come up to cos x. And that's how we learn, basically. We practice and we fail, and then at some point we understand how to do it. All right, so any good news? Anyone found the identity? Let's see whether we can, just as a, just for curiosity, you may want to know that whenever you are dealing with any such identity, you might be able to find different ways to go to the same point. It's not like you have just only one single path. There might be multiple paths. There might be, you may be able to apply different things and still you will be, but some of the paths may be easier. Okay. At this point, I think something which might be applied here, but that may not be the best one. You can find something else to go there. So let's see what I think that might be suitable for here. For an example, for sec x, you can think it as a 1 over cos x, right? Because I'm just copying from there. Look at the reciprocal identities. For sine times tangent, what I can do is, for tangent I can write sine over, let's work only with the left hand side, right? Left hand side, sine over cos, right? So I'm just taking the quotient identities for the tangent. Now here, I can write 1 over cosine minus, here for the second part, I'm writing sine square over cosine. Because sine and sine are multiplied, right? That becomes sine square. Now, for this part, if I take the common factor here, so I'll write cos x in the denominator and the numerator x, right? So far this is right surprising.
So 1 minus sine square, we can write what? Cos square, cosine square. So 1 minus sine square is nothing but cos square divided by cos x. You can see the answer right now, right?
Which is nothing but cos x. It's something like x squared divided by x. There are 2 cos x multiplied, you are just cancelling 1 by the denominator cos x. That's how you can get cos x. Any question here? Remember, you might have something else, or you might be able to find some other steps to go to the same point. But this is the best I can think of right now. Any question here? I think one is applied, is simple, but the crucial point is what to start, where to start, or what to apply. Okay, So we have some steps there. I think we can, I'll talk about that steps. So a lot of times those steps help. Let's look at this one because I don't want to skip any of those, just to make sure that we look at different variety of identities. So let's write it down, and then I'll go to that identity page where we have all the formulas written, so that we can see which one can be applied. This is probably the easiest one out of all of those so far we tried. Just write it down, and then we'll go back to that page. So identity cot square x plus okay, so let's go back and see whether you want to try. Okay, so these are the identities we have. Let's try for a minute. All right, so any good news? Anyone found the identity? I can, what I was thinking was like this. For an example, look at this. You want to find cosec square x. This is one way of
finding cosec square x. This is only one formula you have where you can directly get cosec square x. And the interesting part is in the left side you have cot square. Here also in the left side you have cot square. So all you need to do is you have to find 1 from here, which is already 1. You know that the sine square plus cos square equals to 1, right? That's already there in under the Pythagorean identities. You know, I'm just trying to show you that idea, that how you can get there. So in the right side you have cosec square x, in the left side you have cot square x. Only you needed was a 1 added to the cot square x, and the sine square x plus cos square x is already 1. So in the Pythagorean, this is probably the easiest one out of all the 3 we tried so far. Again, there might be another way of getting the same answer, but this is probably the easiest I can think of right now. It's not the only way for sure. But sometimes what happens is this: if you choose some the wrong identities, it will be so complex. At the end, you will have the same answer, but you know, let's say you just wrote for cot x, you wrote cos square minus sine square, and then you are trying to add, and then you are trying ratios, but you will get the same answer, but it will be more complex. You will get there for sure. Any question about this? All right, so let's see how much time we have. So we're almost at the end. Let's see, we can try. So probably this is going to be the, let's see, we tried this. So let's try this one. This is going to be the last one for today. We'll stop here, and then later on we'll resume from the next slide. And I don't want to skip any of those so that we can do a lot of practice, since we have little more time and we save little time for tomorrow, starting this section today. So tan square x minus sine square x equals to tan square x times sine square x. So let's write it down and go back to those identities. I'm going back to that identity and see. Oops. All right, so let's see whether we can solve it. All right, so let's see whether we can solve it. So we will be working with the left side only. So the tan square we can write, you know, tan square equals to sine by cos. So we can write sine square by cos square from the quotient identities. Just to make sure you see this, right? Tan x equals to sine by cos. So tan square means sine square by cos square. You are just
applying the whole square, minus sine square. And then let's take the LCD for this one. See, so the cos square x, and then here you have sine square x minus sine to the power 4x. Do you see why it is sine to the power 4? Because this is I'm sorry, that's not sine to the power 4. This is sine square, and this is sine square x, cos square x, I'm sorry, because that's cos. Sine square x times cos square x. Okay. Now, from the numerator, we can take sine square as a common factor, right? Then it becomes 1 minus cos square x. Denominator, we have still cos square x. What is next? So, sine square x, let me go here. Sine square x times you see what we did? Sine square x times sine square x, because 1 minus cos square is again sine square, right? And the denominator is still cos x. Now if you take these two as a ratio, what do you get? 10 square, right? Because the sine by 10 is, cos is 10, sine square by cos square equals to 10 square. Now you already have the identity, so 10 square x times, that's what exactly you wanted, right? Any question here? Alright, so we'll stop here and we'll resume from the